This is a new group of problems from your book. In the following exercises, find the Taylor series of the given functions centered at the indicated point. This is similar to what we did before. We did stop at the second derivative, however, or the P2 for these. So here, it looks like in our number 140, we can take four derivatives of this, and in 141 we can take three, and then everything after that's going to be zero because the fifth derivative of x to the fourth will be zero. So we have a terminating point, so these shouldn't be too terrible. All right, so we have f of -1 because that's our a. That's going to equal just 1 because it's to the fourth power. F prime of x is going to be 4x cubed, and f prime at -1 will be -4 because we've got a constant or an odd number for the exponent there. Second derivative is 12x squared, which means the derivative at -1 will be just positive 12. Third derivative, 24x, which makes the derivative there, or the evaluation at -1 there, negative, so -24. And finally, f to the fourth derivative is just 24. And that's what it's going to be at that. So we also know that the nth derivative of x will equal 0. And that'll be for all n at least 5, n greater than or equal to 5. So now we've got to put this together. So our Pn in this case is 4. I guess Pn it doesn't matter. We'll just do Pn because everything after that's going to be chopped off anyway. So our first one, we're going to have 1 over 0 factorial. Our next one will be 4x cubed, excuse me. Let's do that again. No, that's all wrong. I'm looking at the wrong thing. It should be -4 there. So we're going to subtract 4. And then we have x minus a, so that'll be x plus 1 minus -1. It'll be over 1 factorial. We're back to positive 12, and then we're looking at x plus 1 squared over 2 factorial. And that's a minus, not a plus. Minus 24 x plus 1 cubed over 3 factorial. And finally, plus 24 x plus 1 to the fourth, or 4 factorial. And then it'll just be plus 0. All of the rest of the terms are going to be killed at that point. So what does this equal? This is going to be 1 minus 1 in the bottom doesn't matter, so x plus 1. And 12 over 2 is 6. And 24 over 6, because 3 factorial is 6, is -4. And let's see, 24, 6 times 4 is 24 over 24 is just 1. So that's just going to be x plus 1 to the fourth. That's how we do that problem. All right, let's see what we can do about this other one here. Let me just write this one down here. Go from below. Kind of ran out of room on the side there. It's going to be a equals -1. So this was 141. And this was 1 plus x squared plus x cubed at a equals -1. That's the problem we're trying to do right now. Okay, so we're going to do the same basic process. F at -1 will equal 1 minus 1 plus 1 minus 1. That's 0, looks like. F prime at x, it's 1 plus 2x plus 3x squared. And the derivative at negative 1, 1 minus 2 plus 3, so it looks like 2. All right, second derivative, 2 plus 6x, so the evaluation there. It's 2 minus 6, or negative 4. And finally, the third derivative is just 6. So that means f third derivative at negative 1 is also 6. And we have the same situation. There's a 0 after that. So f, I guess, x n power of x equals 0 for all n greater than or equal to 4. So Pn is going to equal, our first value is 0 over 0 factorial plus 2 over 1 factorial. And we're multiplying this by x, again, plus 1 because it's x minus a. And then we got a minus 4x plus 1 squared over 2 factorial. And then 6 is our next number. And then we add 0 there. Everything else after that, 0. So finally, this equals 0 plus 2 times x plus 1. 4 over 2 is just 2, so minus 2 times that quantity. And 6 over 6 is 1. So we don't need the 0. We can probably get rid of this. And just start off with the first term is going to be 2 times quantity x plus 1.